Good morning, HPC fans, and welcome back to St. Louis, Missouri. We're here kicking off day one of our 3 days of live coverage on theCUBE. My name's Savannah Peterson. Honestly impressed by the brain power on the desk next to me. Alan, Mark, and Gary, thank you so much for coming to hang out this morning.
Thank you.
It's great to have you all. The day is hosted by Solidigm, which is awesome. We love you all. Thank you for doing that.
Of course.
And you brought some really special guests up to the desk with us today. Alan, tell me a little bit about these gentlemen and why you brought them with you.
I don't know that they need to be introduced. Gary is kind of like a mentor to I'd say the industry for parallel NFS file systems, and the work that their team does at Los Alamos National Labs proliferates throughout enterprises as time goes by, and they're kind of the main pathfinding organization for all of the things that run parallel together. And Mark, I think Mark's been probably forgotten more about storage than I'll know. But to give you an example, the file system that they're developing, when we installed it, it immediately blew away every benchmark that we've ever run our SSDs on. So that gives you just a little bit of insight into the two gentlemen sitting to my left.
No, I love it, Alan. You spoke so highly of them as they were getting settled. That's why I wanted to give them that loving intro. Everyone needs to hear the nice things their friends have to say about them.
Good.
Mark, people might not have heard of your company yet. You were recently out of stealth 2 years ago, obviously crushing it already, given that you're on this stage. Give us your pitch. Tell us about PEAK.io.
Clearly, I've been around storage for a long, long time. And PEAK.io is really just an evolution of storage, but with a bit different angle, in accepting that, one, the industry has moved on, the use case has moved on, and the reality is Solidigm make amazing drives. At the top end network, people make amazing network. Actually, it's not as magic as it used to be. So our job has been to recreate that traditional storage stack that really just take advantage of all the amazing work that Solidigm have done and get it out to the user in a way that they want to use it. And, I'm sure our development guys will hate me, but, these guys have done most of the work. These guys do most of the experimentation and tell us what we need. We're just connecting dots in a way that works with the new world.
That's such a humble, lovely way of putting it. I'm sure it's a little bit more complicated.
I'm sure it is, but I'll take it humble.
Gary, you work in one of the most important labs in our nation, probably the world, depending on how you look at it. Talk to me a little bit about why partnerships and conversations and collaborations with folks like PEAK.io and Solidigm are so critical to your business.
We manage the nuclear stockpile for the U.S., and we're not necessarily in the build computers business. We're in the buy computers business. The problem is we tend to run into problems a few years before others do because of scale or needs. We try to align ourselves to industry as best we can, but oftentimes we're some number of years ahead. And so the only way that we can field systems that are truly usable for us is to work with industry to sort of pull the things we need along sooner than they might occur otherwise. So we find ourselves in an interesting position of sort of being a pseudo venture capital in a way. It's kind of weird, right? And we actually work with venture capitalists a lot because we'll be funding some certain technologies or pushing some direction, and some other part of the world may need it. And so venture capitalists will partner with us to make these sorts of things happen. So anyway, we kind of have a technology development arm to feed our technology need.
So you're sort of the tip of the spear when it comes to HPC in a lot of different ways.
Yep.
So what happens when you reach a juncture, Gary, where you realize you need something better, faster, whatever that might be, higher performance? How do you figure out who to call? How are you deciding on partnerships? I would imagine there's a level of secrecy here too.
Well, it helps to be ancient and know everybody.
There's one advantage of it.
That's right. And I think that's super important, right? I mean, you try to maintain relationship with all the tech players in many fields, memory, storage, processing, whatever. the data centers, all that stuff, right? But it's hard to keep up with, all the startups and things. But we have lots of friends that aren't in this industry. They're in DoD and there are other national labs, and they're, the energy sector and the aerospace sector. And it's kind of a fairly small club of really super high performance kind of things. From a simulation point of view, there's certainly a lot of AI now, but and so we all talk to one another a lot. And they, whenever they say, gosh, Gary, you should go look at this, I go look at it because there's smart people doing really, really interesting things. And chances are whatever they tell me is probably something I should follow up on, which is exactly what happened here. DoD whispered in my ear and said, Gary, those guys are really good. You need to talk to those guys. And that's what I did. I went and talked to them.
And to give Gary a bit more kudos here, it's actually rare on our side, because the traditional model is people like myself create in stealth the next generation, and then we evangelize it as if that's the answer to everything. But the reality is this is the new world. It's a new world in AI. It's a new world, as Gary's saying, he's discovering problems 2 years ahead. So to have somebody like Gary that's actually telling us the problems that are realistic and are going to happen influences what we design. So we can take Solidigm and make it into a rocket ship and make, like every square inch as fast and as economical and as amazing as possible. But to deal with the problems, you actually need to know what the problems are. Not tell the world what the problems are, but actually understand them. And so,
louder for the people in the back, Mark.
Yeah, and
seriously.
And it's rare that we have the opportunity to either A, as the new start, to work with people like Gary that can communicate those problems and will work with us, and B, we're not locked into our vision, and we are the ones that are telling the market where to go. So it's been a two-way street where we've really learned a lot from Gary. Gary's really helped us transition from a really fast Solidigm box to what happens when you put 100 of them together, and transition to that next scale, dealing with modern day problems in a way that we couldn't deal with 5 years ago. Solidigm today are nothing like they were 5 years ago. And so this is new tech. It needs new software. It needs new stack. It needs new logistics to make it deal with new problems. And without Gary, we wouldn't know those.
Yeah, I think that collaboration is really important. You said something, Mark, I just want to highlight. There's this notion sometimes in technology land that if we build it, they will come.
Yeah.
Like, oh, sure, we know how to read a problem or whatever that is. And the reality is you don't. And if you're not part of why I wanted to ask you about that, is it's got to be, I say this really lovingly, it's got to be a pretty tight community, to Gary's point, of folks who have the trust even within that nest of super high performance computing, simulation, and especially things that relate to national security. I mean, we're not talking about something light and fluffy and putting a photo filter on us with AI. We're talking about things that really impact our lives and our safety. Alan, it's got to feel kind of cool for you to sit here and hear them talk about working with you.
Again, two I consider mentors of mine, and kind of legends in the industry. But if you think about the combination of the work that we get to do together, and you kind of alluded to it, if you build it, they will come. When we built SSDs at Intel, I don't know, 20 years ago, Avi was talking about it. It took a long time for client PCs to catch up. And now I think we're at the cusp of AI being introduced into the world, and the server side catching up to the amount of bandwidth that you can drive from a single solid state drive. And to Mark's point, for what Gary does on a daily basis, when you start to scale that into hundreds and thousands and rack after rack after rack of storage, getting that data somewhere to a compute engine is really kind of I think the next bottleneck is going to be, we have to go fix the network maybe, but that's kind of the prediction that we're at, because now I've got software that'll do very cool stuff.
What do you say, Gary?
He'll fix that too.
Yeah.
Gonna fix that too.
I love that confidence. There's a lot of friend love on this news desk. There's usually, a healthy partnership and relationship. You can tell y'all really respect each other. Frankly, it's kind of refreshing. Mark, you recently had an announcement. Tell us about your recent announcement.
Yeah, sure. We've been working with Gary for a while now on, we all understand what a parallel file system is and we all understand the benefits. But if you think back historically, when many of us made parallel file systems, technology was different. The user was different, the needs were different, the capability was different.
Everything was different.
And so it's difficult to take something that's 20 years old and make it current, because there's a lot of legacy there. There's also a lot of people supporting that are retiring, as they should do. And so sometimes, a bit like PKIO, it's almost easier to start again and say, actually, I don't need the legacy. And that's not being derogatory to anybody, but we need a newer standard that takes advantage of what people have today. And I think one of the biggest lessons I've learned with Gary is that can't be proprietary. The moment you make that proprietary, then it's not a standard and everybody else isn't going to join in. And you need more than one person to make something good. So we've been working on pNFS, an open version of pNFS for, I don't know, maybe 12 months more, to which now Gary's kindly loaning in the lab where we're doing the testing. And we're proud as a company to be able to say, this is now open. You know, you go and take it, go and use it, or we can productize it and work with you. And so pNFS has become, through Gary to be fair, has become more of a standard. We've seen other large vendors announce that within the last few days. And I'd love to say it was an amazing strategy of ours that we started developing this 12 months ago, 18 months ago. It was actually the 2-year advantage of Gary that pushed us towards
the
pNFS.
Gary advantage.
We were going a different way.
I like this. It's properly branded now.
Yeah. So
Yeah,
it should be trademark Gary. You should have royalties on this. So yeah, pNFS we've announced. We're getting great results. We're still working with Los Alamos and Gary. We're really looking forward to taking this to another level. And one that is different insofar as not everybody is Los Alamos. Not everybody has 20,000 nodes. Some people today start with 1 or 10.
Totally.
So the different approach that we're trying to say is, hey, look, Solidigm have done an amazing job, and one node might suit you for your innovation. Hopefully you're going to grow to $1 billion company. The difference with our parallel file system, as well as being open, is that it's automized so that we can, as you grow, add another. And it doesn't need
modular,
the same resource that we used to. We've tried to take away the complexity that is normally associated with real high-performance file systems.
And the commitment you have to make to something out the gate without the ability to modify it at all. I mean, it's really a game changer. And you're combining agility with open, with both of those things that you just talked about, which really matters. We had a nice debate this morning on the news desk about standardization. One of our other analysts saying that she didn't feel there was a lot of standards at all. I think this community is actually very pro standards. We're here for things working. We don't need to reinvent a very expensive wheel every single time we go out and do something or modify a stack or change a system. All right, Gary, I got a question for you. Since the Gary advantage is clearly revered and celebrated by these two gentlemen, if you could, and this can be a little hypothetical, I realize, well, you can answer this however you want to answer this. If you could wave a magic wand and solve one of the challenges that you have at work right now, what would that be? What are they going to build you next is where I'm driving with this.
Well, there's a couple of pieces left in pNFS that we have to do. At our site, we might have 1 million writers writing into one file.
Wow.
So 1 million processes all writing into the same file. That's the reason Lustre exists. That's why we paid for Lustre to exist 25 years ago. And we need to get that capability put into pNFS, and it's a community effort. The client's got to change. It's got to all happen. And so there's that. There's scalable metadata within pNFS. It's one thing to get the fastest single metadata server, but If you need to scale beyond that, which we always do, then you need to figure out ways to scale it. There's not too many parallel file systems that have scalable metadata, and arguably almost none of them, if not none of them, got it right.
Yeah.
I paid for most of them, oddly. And so those two things need to happen, but my real problem is actually not even in this space. My real problem is in horribly misaligned memory accesses. Horribly misaligned memory accesses.
Interesting.
And so it's hard to use a GPU or anything if your memory is not well aligned so that you can do data parallelism. And why is the memory not aligned? It's not aligned because we're trying to run a problem that's 1,000 times bigger than the machine I have. And you might say, well, gosh, Gary, you've got a machine with 2 or 4 petabytes of DRAM. Why isn't that a big enough machine? Well, it's not, by a factor of 1,000.
Right.
There's not enough money ever to buy the machine you need to solve the problem. So you've got to represent those bits in some way that's sparse and irregular and compressed and access the data that way. And so that's a decadal problem. But it's interesting. pNFS was a decadal problem. We started pNFS in 2002 at the University of Michigan.
I was literally just there yesterday.
Which is where, really? Yeah. So where Trond actually came from after he was in Oslo, right? And so, who is the kernel maintainer for NFS client. And we said we need to head down this path to have a standard community-based parallel file system capability. We did Lustre, which was open, but it wasn't standard. So we needed a standard, right? And it took this long to get there. It took a long time to get the right piece parts, the right emphasis, and had it not been for AI, it's not clear it still would have happened.
Yeah,
right? I mean, there was a market pull that pulled it that helped us along. But we've been at this for a while. We recognized the need for it in 2001.
Yeah, you were certainly self-aware enough. And I'm glad you brought that up. I'm sure you both probably seen this. I mean, AI has really accelerated and compressed the innovation cycle in a way that makes us move a lot faster.
Yeah, actually, I would kind of echo, the funny thing we were talking about, the server side is finally catching up to the storage performance that we can do, and maybe the network's the bottleneck, but then there's also this next probably 4 or 5 years where this memory hierarchy problem, think about it, the further out you go, the more dense the memory is and the slower it is, and as you get closer to the GPU, it gets smaller and faster. But this whole thing needs to start lifting and making that happen and making it work in parallel and making it work at a scale where Gary can solve problems is going to take a lot of work. So there's many, many, many more years of innovation that we have in front of us.
So you're still going to have a job in a little bit. Yeah, it's not going to take your job.
So as soon as I'm off of this, I have to go back to the lab.
Yeah, yeah, exactly. All right, I have one final question for each of you. I'd love if you could all answer it. Mark, I'm going to start with you since you're giving me the nice eye contact right now. When we're at supercomputing in 2026 in Chicago, what do you hope to be able to say then that you can't say today?
Storage, by all of us, all of the storage vendors, will continue. There's an amazing use case for that. However, personally, I feel that we've now reached a point where technology allows us to not disaggregate storage or not separate storage in the same sense that we do now. So it's isolated, it's used over a network, it's all got drivers and it works within a standard. We want and are actively working of taking everything that we've done and we've learned and we made and pulling that within the ecosystem more so that it doesn't see it as a separate entity or as a separate project or vendor. It's just part of the job. You need a petabyte or 20 petabytes, it magically appears by using Solidigm everywhere. And so that's what we will hopefully be announcing next year is we'll continue with our storage roadmap, but we'll have more of a virtual roadmap of storage within inside the ecosystem that's being more dominant nowadays.
All right, look forward to talking to you about that in 2026. Gary, what about you?
Well, Mark said the magic word ecosystem. And to get an ecosystem, you needed a community. And so if I came to my 37th supercomputing or whatever number it is.
It is 37.
It is, yeah. So, and there was actually 2 before that weren't called supercomputing, but anyway.
Fun.
And so,
I love that you know that.
what I would hope to see is a growing, prosperous community around pNFS. The open standards variant of it, as well as industries that are closing parts of it off. If we don't have a large ecosystem, we don't have a 20-year roadmap for taking care of my needs so that I can go do something else, right?
Yeah.
And so I think that's what's needed. That's what we've been after. That's why we're funding this test bed area for people to go use. That's why we care, is we need with Lustre, we had a 20-year time span. That's a long time for a piece of software to live. And it survived because it was open and there was a community. We have to have that same thing happen again, but this time not just be open, but also be standard.
Yes.
So the community could get much, much larger, and I can forget about this problem and go do something else.
I love it. Honestly, you just touched my cold, dark technology heart by saying community, because we talk a lot about specs. We talk a lot about gadgets. We talk a lot about things that are very specific that in a year or 2 will be updated. They will be modified. They will be changed. But the people will still be here. And I'm so glad you said that. It just, yes, we don't talk about community enough in Nerdland, and that was a great soundbite, Gary. Alan, what about you? What are we talking about in 2026?
Oh, I would love to be able to sit up on the stage with 2 legends again.
Okay,
and
check.
say that
We'll put that on the
we've
count.
actually made progress from where we are now, and that we have a better direction in the future. And I would say, to both of their points, there's a great community that Gary has called EMC3. There's a couple of other communities that are available that are standards bodies, and even NVIDIA is trying to drive some new storage stuff.
Mm-hmm.
So I would say that having the opportunity to have leaders like that in the community that are, taking care of the greater needs is very important. But I think that there's a lot of smaller companies like ours and others that still need to step up. So I think that I would love to see it in a year where we could have the discussion of how we've proliferated that.
Well, I can't wait to have it with you. It's going to be a great time, Alan. Alan, Mark, and Gary, thank you guys so much. What a wonderful way to kick off the show. This is awesome.
Thank you.
And thank all of you for tuning in to our thrilling, exciting, educational, hopefully inspiring 3 days of live coverage here in St. Louis, Missouri at Supercomputing. My name is Savannah Peterson. You're watching theCUBE, the leading source for enterprise tech news.